Good morning, everyone. We are just waiting a couple of minutes to allow um, more people to join the webinar. So we'll wait just a couple of more minutes before we begin. Thank you. Good morning, everyone. Once again, we welcome you to today's webinar, Classic and Modern Integration of Culture Methods and qPCR for Listeria monocytogenes control. So my name is Aletia Cruz. I am a microbiology product manager here at Condalab, and I'm sure I've met some of you before in another webinar talking about standard method, reference methods, and today we are joined by my colleague Pilar Rodriguez as well for the presentation.
Hello, thank you, Aletia. Thank you all for joining us. My name is Pilar Rodriguez. I'm a rapid microbiology product manager in Conda Lab, especially in our Condashine line, that is the real-time PCR line for food industry. So thank you all for joining us.
Thank you. So let's begin. We have a lot of content today for you. So the first one is about, of course, Listeria monocytogenes, the pathogen, its relevance in public health. Then we go on to the surveillance, the transmission and control, the food vehicles that are involved, and of course the subject of cross-contamination. We're going to get into the legislation here in the European Union because there has been a modification to the regulation. We are going to talk, of course, about conventional and alternative methods, a comparison of techniques, but also the combination of both, how we can use them simultaneously. And then for the implementation of an alternative technique in an accredited laboratory, the preliminary checks. And well, this is just a guideline of how are the steps that you can take to have to use an alternative technique in your laboratory that is not so long as a full validation. And then we will present you the Conda Lab solutions we have. We have a couple of products available, new products available. So we're going to talk about that, Conda Gene Solutions. And then, as you know, always we have a small Q&A session for everyone. So you can send all your questions that you have, and we will answer them after the presentation. So we're going to begin.
So I will start with a brief introduction of Listeria monocytogenes. You may all have heard about it because it's a common pathogen in foodbornes. Wait a second. Yes. So, sorry,
Yes, just
Aletia, maybe you
Carla.
can.
Yes, just a second. We are almost there. So, yeah, we are here once again.
Perfect. Thank you. So, as I was saying, Listeria is a common bacteria in foodborne. So we will talk a little bit about the characteristics of this one. Listeria monocytogenes belongs to the Listeria family. It's a gram-positive bacillus. It can survive in a wide range of temperature between minus 18 Celsius degrees to 45 degrees. Its optimal growth temperature to duplicate is between 30 to 37 degrees, but it can also do it between 2 degrees to 45 degrees. So that's why Listeria is a big problem, because even we have our food in the fridge, it can duplicate there. So it's really important the control to eliminate it and to detect it. Also, this bacteria can grow in a wide range of pH between 3.3 to 9.6, and also can create biofilms. As you know, when a bacteria creates a biofilm by adding to a surface and colonize it, it's harder to eliminate it. So this is also another characteristic for Listeria that make it a big problem. And because of all of this, we can find it in a lot of places, as can be soil, water, farm environments, also the animals that live in those environments. Because of the biofilms, we can find it in food processing equipment, because in that kind of surfaces, it can also create the biofilm. And because of that, we can also find it in ready to eat food and fruit and vegetables. Let's move now to the public health relevance. When someone eats something that is contaminated with Listeria monocytogenes, it can cause them listeriosis. There are several risk groups, such as pregnant women, immunocompromised individuals, and people over 65 years of age. The symptoms of this illness can vary depending on if it's a mild or a severe cause. In mild cases, it can cause fever, muscle pain, vomiting, diarrhea, and in the severe cases, it can also cause sepsis, meningitis, or a spontaneous miscarriage in pregnant women. The mortality rate in the severe cases is really high, and it can be up to 30%. Now, if we take a look to the latest EFSA report, we can see that a total of 2,952 cases of listeriosis were reported in the European Union during 2023, and this is the highest number since community level surveillance began in 2007. The notification rate was 0.66 cases per 100,000 inhabitants. And if we compare this number to the number that we had in the EFSA report of 2022, it represents a 5.8% of increase. Also, we can talk about the risk group. The 80% of deaths occur in people over 65 years of age, and this, well, of course, reflects the vulnerability of this group to listeriosis. If we see all this number and the whole report, we can uh, we can say that we need to keep talking about listeria and listeriosis, because the reported cases are growing. The notification rate too. So we have to to keep talking about Listeria, how to control it and how to eliminate it, because it's still here and it's still a problem.
Yes, and for that, we're going to talk deeper about the surveillance that is being done for Listeria monocytogenes. and the transmission and the control as well. We've recalled the danger that these pathogens poses to public health. Um, in the One Health report on zoonosis, the latest report, the increase mentioned by Pilar that was observed was both in cases and notifications, as we can see here on this chart on the left. In 2023, 19 outbreaks and cases related to Listeria mono were identified. It is very important to mention that foodborne outbreaks are categorized either as weak evidence or strong evidence outbreak, which is just based on the strength of the evidence involving a specific food vehicle. We're talking about a food vehicle. So the evidence can be epidemiological, microbiological, descriptive of the environment. This can be an on-site health inspection, for example, or even, of course, based on product tracing. For these reasons, evidence of an outbreak is categorized as either solid or weak. And of these outbreaks in 2023, more than half were supported by weak evidence. This again tells us, as Pilar said, that there is still a lot of work to be done in terms of surveillance and notification for Listeria mono. On the other hand, actually, thanks to this report, we can know the main food vehicles involved, the most relevant category, pig products and products thereof, responsible for 3 outbreaks, and fish products, 2 outbreaks, and just the rest of the categories that we have here are related to 1 outbreak, and these were vegetables, juices, and products thereof, milk, and cheese. Continuing with the results of this report on food vehicles, during the distribution of the products, it was found that more than half of the ready-to-eat food categories, the proportions of positive samples for Listeria mono were 0 to very low, actually less than 1%. And the proportion of samples that exceeded 100 CFU was also 0 to very low in all of these categories. While, on the other hand, during production, we can find the same ratios of null to very low positive samples in 4 of the, in this case, half of the ready-to-eat food categories. Products of meat origin, fermented sausages, were identified as the main category with positives and samples that exceeded this limit of 100 CFU per gram. This data, of course, indicates us that certain products, the controls just appear to not be sufficient, while for others there may be cross-contamination, especially as a result of poor hygiene practices during the storage, the handling, and the preparation of these foods. It should also be reviewed whether it is necessary to increase control points throughout the complete chain, as in the primary chain, since in this stage, the member states that are reporting the data are very few due to the lack of harmonization of sampling and control during this primary stage. This is the picture of how it is regulated in the European Union. Of course, we have the regulation 2073 from 2005 that establishes the microbiological criteria for certain microorganisms, including, of course, Listeria monocytogenes, due to its high fatality rate, as Pilar mentioned, and the application rules that food business operators must comply with. The food safety criterion for a product contaminated by this pathogen is a level above 100 CFU per gram, especially when we are talking about ready-to-eat products. And because, there is no treatment such as, cooking, high cooking temperatures, or any other treatment to eliminate this pathogen. This limit has been set for consumers who are not, this is very important. We have to keep in mind that this is for healthy consumers. So this is not for infants or people that have an impaired immune system. For them, it is necessary to check the absence of these bacteria in 25 grams of food sample. However, we are just talking about the manufacturing stage. This is all during manufacturing. This regulation 2073 does not establish a criteria after leaving this immediate control of the manufacturer, although it is not possible to guarantee that during the complete shelf life of the product, the limit of 100 CFU per gram will not be exceeded. And as we've mentioned, the EFSA has observed and reported an increase in cases, more particularly between 2019 and 2023, which is the year of this last report, and that the number of deaths in 2022 has been, and this is very shocking, one of the highest figures in the last decade. So just 3 years ago, it was the deadliest year regarding Listeria mono. And due to all of these reasons, an amendment to Regulation 2073/2005 was published, which is Regulation 2024/2895. It was just published in November last year to ensure this same level of protection to public health from the manufacturing stage to the distribution in ready-to-eat foods. This criterion of absence of Listeria mono in 25 grams for the entire shelf life of the product. So in this slide, I think it's more obvious the modification of Regulation 2024/2895. Previously, we could say that the control ended in the production part or stage. Of course, there was a surveillance in public environments, but right now we have a tighter control basically on the entire shelf life of the product, from the primary production in some cases, of course, all the way through manufacturing, distribution, retail, and public settings. In both cases, we can notice that the only exception is the domestic environment. Again, due to the lack of awareness or poor hygiene practices, there may be cross-contamination, but this, of course, would not cause an outbreak or a problem for public health. In this setting, the goal should be just to raise awareness amongst us consumers about good hygiene and storage practices. As we can see in this table, the Regulation 2024/2895 for ready-to-eat foods, which again, I must be very clear about this. These are not intended, a product not intended for infants or for special medical purposes. This limit will be of 100 CFE per gram in case it is demonstrated that Listeria mono will not exceed this limit during the entire shelf life of the food. In the event that this condition cannot be demonstrated, the limit will be the absence of Listeria mono in 25 grams, but this criteria will apply throughout the shelf life of the product as well. In both cases, of course, the reference method is by culture media, ISO standard 11290.
So now we will talk a little bit about the conventional method and also the PCR, that is an alternative method to detect Listeria monocytogenes. We will start with the ISO method. For this one, we will have to start with the enrichment step. First, primary culture in hard freezer broth, and then a second enrichment in freezer broth. Both of them takes us 25 hours. 25 hours to continue with the next step. That is the presumed isolation, that here we will have to do at the same time. First in the aloe agar, that is a chromogenic, and also in Oxford agar or Parkman agar. In the aloe, that is a chromogenic medium, we will have we can see Listeria spp and also Listeria mono. Listeria spp as blue-green colonies, and Listeria mono is the same, is a blue-green colony, but we will have the presence of a opaque halo around it. And then if we can see these colonies, we will move to the isolation of the suspected colonies, in this case in a non-selective media or non-selective agar, as can be a nutritive agar or blood agar number 2. And also leave it there from 24 to 48 hours. And then we will move to the confirmation step. This we will do it with microscopy or with biochemistry techniques. For Listeria spp with microscopy or a positive catalase activity, and for Listeria mono microscopy or an hemolytic activity that has to be positive. Then we can talk about real-time PCR. We have to start as with the ISO method with a primary enrichment in Hall-Fraser broth, and with that one is enough. And from then we will move to the DNA extraction step. We just have to take 1 milliliter from this enrichment and centrifuge it, and we will form a pellet. And from that pellet we will do the DNA extraction. These steps can take us from 20 to 45 minutes depending on the kit that we choose. And once we have the DNA extracted, we can move to the detection step. That this is just to dispense the reagent that comes in the kit in the PCR tubes, add the DNA that we extracted in the previous step, and program the thermal cycler. And this whole step can take us 2 hours until we have the result in the thermal cyclers. As you can see, the PCR is faster, and the sensitivity of the technique is higher. But what we want to share with you is the possibility of using the both techniques to optimize the process. As PCR is an alternative method, so we have to follow the ISO method. So we can combine these techniques using the PCR as an screening. We can do it just at the beginning when we start with the enrichment. We can just take the sample from there. In case that we have a positive result here, we just can avoid some steps then, or for example, minimize the time of the enrichments. And also, if we have a positive here, we just can take measure of our batch or whatever we are testing. The screening, we can also do it when we finish the enrichment, in case that we have a negative result here. So we can do it at the end of the enrichment, because maybe we have a really low quantity of Listeria, so we can do it there. And also we can use the PCR as a confirmation technique. As I already said, in the aloe agar, we have it can grow Listeria spp and Listeria mono, and sometimes it's hard to differentiate if it's one or the other. So we can just take the colony from there and do the PCR to be sure that is Listeria mono. And also we can do it to avoid the biochemistry techniques. Yeah, so in this case we can save time, space in the lab, and supplies. And of course, I think that the best thing that can give us the real time is that we can have a fast answer against foodborne and suspicious batch and take measures of it. So this is the way that we can combine them and optimize the ISO method.
So now, since we've seen how we can use both techniques, the standard method and an alternative fast method, both for the analysis of Listeria mono, we're going to go through, like I've said, a guideline that was proposed for a simple way to implement an alternative technique such as Condegene in an accredited laboratory. Um, This information is advice from experts that is driven by the industry's need for more agile ways to introduce a new technique in a laboratory. To do this, we have some preliminary checks that must be considered. The first is a preliminary verification and validation check of this method. That is, we just need to confirm that if the alternative method of interest is validated for the target matrix, and also to evaluate the equivalence of this alternative method against the reference method or another alternative method. We do this by checking third-party certifications such as AOAC, AFNOR, Microval, NordVal, and we confirm the target food matrix, the test portion size, and also, very important, the enrichment protocols. Pilar has highlighted the importance of this stage of the enrichment. If our matrix and conditions are included, meaning validated, we can proceed with the first use verification of the alternative method. Otherwise, we must evaluate the target matrix. On the other hand, the competence of the laboratory for the implementation of the alternative method must be demonstrated. To do this, it is necessary to analyze inoculated and uninoculated samples from a validated matrix and compare the results with those of the reference method. In the case of Listeria mono, the ISO standard 11290, of course, the alternative method will be accepted if and only if there are no false positives or negatives, and also if, a second condition, the presumptive results are equivalent. As we have, as I've said, in case the target matrix is not validated, which can be very common nowadays due to the wide variety of products that we can find on the market, we must, on one hand, determine if the target matrix resembles any validated category, either by using intrinsic factors of this matrix, such as pH, water activity, even some ingredients like spices. Um, it is also very interesting to go over the enrichment procedures to find any type of similarities. On the other hand, the IAFP, the International Association for Food Protection, and it's the Applied Laboratory Methods Professional Development Group, developed a decision tool that assigns a score, this table on the right. This suggests whether the type of validation required, if it should be minimal, moderate, or if you should just do a full-on validation. This tool is based on the risk to the consumer versus the risk to the failure of detection of a pathogen. Um, right now, we're just talking about Listeria mono. In a nutshell, it is just a guide that helps us answer certain questions before going over the whole validation process that we know it is very complicated, it is lengthy, or even before performing the analysis of a product to ensure what we are doing is going to give us very reliable results. So next would be the fit for purpose testing, which will give us key information on whether the alternative method in question should be used for the new matrix by quickly screening for obvious detection failures or inhibition issues such as a false negative. So for this, it is proposed to spike 3 portions of analysis and analyze simultaneously by qPCR and the ISO method. These tests will determine whether the enrichment protocols required by the method, the new alternative method, allow the development of the target microorganisms at very important detection levels. This is what we want. And whether there are any obvious effects of the matrix that might interfere with the chemistry or even with the technology of the method. We know that some herbs and spices may have antimicrobial or even just bacteriostatic properties, which would prevent the microorganism, the pathogen, from growing properly during enrichment. Also, fit-for-purpose tests show that the method is suitable for detecting the microorganism, just in conclusion. And finally, we have the boring part or the complicated part of the documentation. We have to compile the justification for the grouping of the matrix, the report of the fit for purpose testing, the results of this risk assessment tool, and of course the comparative results between the alternative method of interest versus the ISO reference method. As well as any internal standard operation procedures for documenting both the operational and the installation qualifications, which are just requirements for regulatory compliance and good practices. And in alignment with ISO 1725, included in the quality system in preparation for an audit review. Now, referring specifically to the regulatory environment here in Europe, we know that the reference method is ISO standard 11290 when talking about Listeria mono, in accordance with the provisions of Regulation 2073 from 2005 and the new modification Regulation 2024-2895. The method validation as of now should be performed using ISO 16140 Part 2 for it to be recognized for an accreditation, and also for the extension of a matrix, it is necessary to demonstrate its equivalence either through internal studies or by an accredited external validation. So, um, these guidelines, as I've said, come from this Applied Laboratory Methods Working Group from the IAFP, and we can only hope that Europe will be next, will be willing very soon to open up to simplify the validation process so we can be quicker in introducing new methods and solutions in our laboratories for a faster response, especially when we are dealing with an outbreak of pathogens such as Listeria mono, which is with its very high fatality rates. In overall, even after going through these guidelines, we can appreciate the relevance of culture media in even in just fast alternative methods, since the majority require and begin actually with an enrichment in a broth and then end by confirmation on a plate. The foundation again continues to be culture media. And finally, I would love to introduce a couple of new products that we have in our catalog. Um, these solutions at Condalab that we are very excited to present are the Fraser and half Fraser broths, both formulated, of course, according to ISO, but now these new references are supplemented, so the preparation is direct from powder to the broth without any need to add any type of supplements. So it is very, very quick to do, and its performance, of course, is very nice as well. And also, as you know, we have all the products according to ISO 11290 for Listeria SSB and Listeria mono, from enrichment to confirmation, both in dehydrated media and ready-to-use media formats.
Moving to the condition solutions, we have the CDL96, that is the thermal cycler. It's an open system for 96 wells with high sensitivity and precision, of course. The software is really intuitive and really easy to use. It contains a data analysis system. It works for detection, for quantification, also for high resolution melting or other molecular biology techniques. It has 4 channels for detection that are the most common one: FAM, X, ROX, and C Wi-Fi. And it's the best thing of this instrument is that it's really easy to program, to set up the programs, to read the results and everything. So it's a really nice equipment. And also we have the detection kit by real-time PCR for Listeria mono. It's an open system too. That means that if you already have a thermal cycler, you can use our kits in your thermal cycler. It's for 100 reaction. It contains an USG for avoiding or eliminating contaminations. It also contains the internal control of the process to be sure of our results, and a negative and a positive control in each kit. And now to continue with the resources that you can find in our webpage, we have some material or a catalog for Condashim, because we have the Listeria monocytogenes kit that I already told you, but we also have kits for other pathogens, for allergens, for animal identification, for spoilers, and also the extraction kits. So you can find all that information in our catalog. We also have a catalog for microbiological analysis in the food industry, where you can find all the workflows as the one that I show you, but for all the pathogens and microorganisms that you have to detect in the food industry. And also we have the chromogenic media solution, our line Condachrome. So you can find also all the information there. So now if you have any question or any comment, you can leave it here in the chat or in the part that says questions, so we can read it and answer. Or even if you, I don't know, need more information about the kits, about something, you can also write us an email and we will try to answer.
Yes, so I have a question here. Why is it recommended to spike the samples? Um, so I think we are referring to this last part, and for the fit for purpose testing. Here it is considered good practice to use stress cultures because it would more closely replicate the state of the pathogenic cells in real samples that we can find every day in our laboratory. So there are options to replicate low humidity environments with freeze-dried strains, lyophilized, or also include heat stress to resemble these thermal processing condition of some of the foods. I have another question. What is an example of weak evidence of an outbreak? So from the regulation that we find that, for example, a descriptive environmental evidence, what I mentioned as an example, a health inspection, alone, just that is almost invariably weak. So there should be more than this for it to be considered a strong evidence outbreak. That is the reason that more than half of the outbreaks in 2023 were weak evidence outbreaks, like microbiological testing to detect the causative agent in the food vehicle or its components, product tracing, and so on. So here is a question, I think, for Pilar. I don't know if you want to answer it.
Okay. I cannot read the question, so.
Oh, okay. Um, it was a question about qPCR, but
Now I can read it now. It's with
okay.
a little bit of delay, I think. So someone is asking if, depending on the matrix that we are working on, we have to change the PCR real-time detection kit. So that's a no. The one of the positive things of PCR is that we can use it for the whole matrices. We don't have to change it. What we have to change sometimes is the extraction kit, because sometimes the sample can contain inhibitors of the PCR, or it can be difficult to do the extraction from the sample. So in those cases, yes, we can choose a different extraction kit, but the detection kit will be the same for all the cases because we will have the DNA, and the DNA will be the same for all the samples.
Great. So I don't know if there's some more questions for Pilar. I know I have a few for myself to answer. But as we've said, any questions that were not answered at this moment, we will answer them by email during these days, these next days, this week. And then again, if you have any more doubts that can arise during these days, you can send it at micro@condalab.com at condalab.com. I hope you enjoyed the presentation today and that it was very helpful. We will be sending you the recording of the presentation, as well as the certificate of participation will be sent automatically tomorrow. And we want to thank you. We appreciate your attendance, and yeah, it was very nice for us to be able to do together this webinar. So yeah, I think we will see you next time.
Thank you so much, everyone, for joining us.
Thank you. Have a nice day.